Good afternoon, everybody. Thank you for being here. I'm Bryan Clark. I'm a senior fellow here at the Hudson Institute, and I'm the director of the Hudson Institute Center for Defense Concepts and Technology. I'm here with Dan Patt, also of the Hudson Institute, a senior fellow here. And we are really honored today to have with us Dave Alexander, the president of General Atomics Aeronautical Systems. Dave is here because we're going to talk about a report that we just released a couple of weeks ago, Hedging Bets, Rethinking Force Design for a Post-Dominance Era. I'm going to shamelessly plug it right here. That report came out and talks a little bit about some of the ideas we have with regard to how the DoD might be able to address the challenges posed by scenarios that are beginning to stress out the U.S. military's ability to deter and defeat aggression. In particular, we focus on the China-Taiwan scenario and how the China-Taiwan scenario is getting to the point where it tends to drive U.S. force design in directions that optimize it for one scenario and make it less able to address the range of possibilities that the DoD may face around the world. So that hedging strategy that we advocate talks a lot about using unmanned systems. And so we want to talk to Dave today about where unmanned systems are going in the DoD, how the world and U.S. military and other militaries are employing them, and what some of the opportunities are in unmanned technology. So Dave, thank you very much for being here.
Yeah, thanks for having me, Bryan.
So you kind of open up, we've seen in Ukraine, we've seen with the operations in the Red Sea against the Houthis, how unmanned systems are really starting to become more than just an adjunct to the manned force, but they're starting to really become the centerpiece of some militaries. And that maybe that's a paradigm shift we're beginning to see. The DoD obviously has been looking at unmanned technology for a long time, but has not really turned the corner necessarily to think of the unmanned systems as a centerpiece or as a mainline piece of the force. Are you seeing any of this shift happening based on your experience with the DoD and General Atomics, or do you think we're still kind of in the learning stages and we're going to follow these adversaries like the Houthis as opposed to leading them?
Yeah, I do think the shift is coming. I mean, for years, we were like flying unmanned aircraft with pilots who wanted to fly real airplanes, right? So it didn't seem like it was meeting their goals in life. But I think over time that has shifted, and so no, I'm seeing it turn. I think for over the horizon, ISR, strike. The past 20 years, I think we've seen that shift, and of course, you have to have air superiority when you have something like that going on. But if you look at what the Air Force is doing with the Collaborative Combat Aircraft Program, and embracing uncrewed mass numbers for air-to-air combat, that's a first. So to me, that's the big shift that we're seeing right now. For years, we've shot Longbow and AIM-9X off of MQ-9 and Gray Eagle, and it never catches on because that's always been seen as a manned aircraft mission. And Secretary Kendall has moved the bar on that, and he's moved it in a big way. And so that's huge. I think it'll go down in history is the time that it was truly embraced.
Right. So on the, I just jump on a follow-on question here. So, you talked about the Air Force, and clearly Secretary Kendall has taken a very kind of forward-leaning look at how unmanned systems could change the Air Force. How about the Navy? So the Navy, in its most recent discussions, I hear a lot of talk about the threat of unmanned systems, how the Houthis have employed them against maritime forces, how Ukraine's operations against the Black Sea Fleet of Russia suggest that there's a threat to maritime forces from unmanned systems. I don't hear them talking about how the Navy could use unmanned systems to make other people feel threatened. Are you seeing the Navy come around?
Well, I don't know if you remember back to the BAMS program, which was kind of a high altitude surveillance Triton, which is a derivative of the Global Hawk. So yeah, they've embraced that. I think what they're missing right now is really persistence in numbers, and I think they're coming around. To be honest with you, we've been doing a lot of demonstrations showing the benefit of what we call MQ-9 Bravo, which is the next generation MQ-9. It's a bigger MQ-9. It has a gross takeoff weight of 13,500 pounds, and it carries everything you can think of, including sonobuoy dispensing and sonobuoy control. So I think the big blue water, long persistence, it's a natural fit. I think it's the next frontier for that medium altitude, long endurance aircraft. I really believe that's going to catch on to the point where probably next year you're going to see some what we're calling Sea Guardian MQ-9B equipped with all this these sensors out there in the fleet.
So let me ask just a little bit more about that. For many people, I think that MQ-9, it's iconic when we think about how the U.S. developed operational concepts to be effective in this Coin CT fight. Right, I have these very long targeting cycles. Right, it really changes the way I have to think about ISR, and of course Reaper enabled this. Right, the concept of a cap and persistence, right. Long targeting cycles. How does this adapt as you think about, say, operations in the Pacific when I have distances which are vastly larger than I would in the CENTCOM AOR? I have scarce basing. What works well, and what needs to, what's changed as you think about things like Sea Guardian? Like, is it just mission systems, or are there other things about the way they're operated that change to adapt to extreme distances in the maritime environment?
Yeah, that's a great question. So, so I don't want to go too far back, but let me just say, going forward, leaving behind manual takeoff and landing and getting into automatic takeoff and landing. And once you've done that, now you can get into satellite automatic takeoff and landing. Those are the foundations for what we call agile combat employment. So now you've got an airplane that you can start, taxi, do your mission, come home, taxi back, shut the airplane off, and you're controlling it from halfway around the world. Prior to that, you had a launch and recovery unit that was where you were operating from, and all these people and pilots and crew, and then you get it up in the air and hand it off to SATCOM. And it was a big mess. There's just people all over the place and technicians to, fix the equipment, and then cooks and, mechanics to keep the vehicles running. I mean, it's just, it just multiplies. The big difference is this agile combat employment, of which the foundation is automatic takeoff and landing through SATCOM. And now you run the whole mission. The whole mission is run through a keyboard, okay? You taxi through what we call an automatic taxi. You take off with the push of the button, and everything's automated. And that is the big change for getting this around the world. The second change, is a useful load of MQ-9 Bravo, which is, like I was mentioned before, 13,500 pounds. But it has a EOIR payload equivalent to, any of the HAVAs that are out there that do maritime mission. It has 360-degree radar that looks out 200 nautical miles, AIS, auto ELINT, comment. That's just standard equipment on there. You can also hang on there sonobuoy pods and then the sonobuoy processor. So when you put all that equipment on this 13,500 pound airplane, you have something way more capable than a P3, and you're approaching capability of a P8. Now, yeah, we can only launch 20 of the large sonobuoys, but maybe you take the radar part off, and now you can maybe launch 40, something like that. So I think you can disaggregate and do a much better job, and it's the marriage of persistence over blue water. So that was a long answer, sorry. But anyway, I had to get my pitch in. So. Yeah.
So, the way we envisioned, unmanned systems helping to complement the traditional force in the report was, looking at areas where, unmanned systems might provide the ability to get the capacity or the scale or the expendability, that you wouldn't be able to get out of the existing traditional force. And that allows you to, hedge against scenarios where those challenges would otherwise cause you to make some really dramatic changes in the manned or the traditional force. So one area is maybe ASW. You talked about anti-submarine warfare, where if you're facing the Yuan threat from China that could create
Yeah.
out of area deployers on the scale of like a dozen or more. It might be hard to keep track of all those with your P8 fleet. You might be forced to use unmanned systems to be able to track them at scale, and that's a way to hedge against that possibility. So I don't have to build a manned force that's able to address that one scenario. I can instead flow unmanned systems to do that. Another way that you talked about is the CCAs with the Air Force and how they're using unmanned systems to hedge against the possibility of a very large air threat being posed by China. The CCA Tranche 1, the first tranche of those, or the first increment of those, is shaping up to be a pretty expensive airplane. And so I think that seems like that's going to run counter to the idea of getting to scale. So how are you looking to, for the CCA program to evolve and get to a price point and a scale that might make it useful in terms of hedging against the possibility of a large scale air threat from China?
Right. So, yeah, I mean, I agree. You have to be. It's a careful mix to get it right, and it has to be attrition tolerant. Okay, but it can't be so expensive that you may as well put a man in it and get it home, kind of thing. So, it's really a balance to get the range, the speed, and the useful load correct, in my opinion, so you can do the long distance as needed, or you can do the agile combat employment where you're island hopping or whatever. I think you have to do both, and the most important thing you have to do is do that without air-to-air refueling. I've seen some concepts where you've got these collaborative combat aircraft sipping off of tankers. And I can't think of any worse Keystone Cop idea that's out there to have hundreds of these little things trying to take fuel when the important the big fighters behind them really need to get on those hoses, if you will, or booms. So it's got to be, do its job and not rely on air-to-air refueling. And I think the Air Force got that part right. Now, as far as the cost goes, there's some numbers out there. I'd say they're off by a factor, if you will. And we will get the price to make sure it's attrition tolerant. Okay. To get to attrition tolerant, you have to build quantities. So it's this whole catch-22, But if you're going to build 1,000 of something, believe me, you can get the price down to where it's affordable.
In your earlier remarks about evolving MQ-9, you brought up moving beyond split remote ops, automatic takeoff and landing. And of course, I want to make sure that our audience recognizes what innovation split remote ops was in the beginning. If just a casual observer, it looks like it's all about the aircraft. And of course, there's great tech in the aircraft. But the concept of split remote ops was really important because it decoupled the mission crew from the operations of the aircraft, again, enables these long targeting cycles, and is incredibly difficult to pull off. You talk about moving beyond that to automatic takeoff and landing, but now as you talk about these CCAs, and in your words, we're envisioning swarms of these aircraft, many of these aircraft, presumably that's a step even beyond automatic takeoff and landing, right? There's clearly has to be some level of abstraction in not just managing the mission, but managing the operations of relatively complex aircraft and machines. How do you see that? How important is this evolution, and how in step are you with your customers about driving the necessary changes there?
Yeah, so without this automation that I'm talking about, and then without autonomy, and then you could argue what's the difference between those two. In some cases, probably not much. But we've been working on this program called Skyborg. We've taken our two company-owned MQ-20s and building autonomy into these airplanes. So in parallel with the CCA development program is all this autonomy software that's going on. And today, I mean, we can fly 2 actual airplanes and bring along 4 or 6 simulated airplanes, put them all in a pattern, and simulate red air coming in, and have them all out through autonomy, all turn like pit bulls and go attack, and be coordinated. Who's got what to shoot, and who's targeting, and who's shooting, and who's mid-course correcting, and that's really where the game is. So it's got to come out of the gate with at least that level of autonomy, and we're doing it now. So that's not a huge leap, you know. The leap is push the button on the tarmac and get out there. So right now it's, you know, get out of ATC and get up and get into the AOR, then go into the autonomy mode. And I think someday it's going to be, the whole distance will be full autonomy. But, you know, if you're operating around a lot of manned aircraft in a tight airspace around a runway, yeah, you got to be careful. And sometimes you want to make sure you're not just relying on software to keep mid-air collisions from happening. But once you're in the combat zone, autonomy on, and that's what will make these. That's how you fly 100 of these at once.
So are you thinking for CCA, for like the increment 1, that those aircraft are taking off from a one-way and making their way, you know, up to the merge with their manned counterparts?
Yeah, I think like was mentioned before, I think you've got to be able to do agile combat employment from maybe the first or second island chain, and you have to be able to deploy from long distances as well. And I think that's the beauty of having the right pinpoint of the design, which is the speed and range.
Right.
You know.
So in another model for CCA, I mean, I think, you know, they're talking about with CCA increment 2 trying to get to a cheaper, you know, more numerous vehicle that may be something that's launched by another airborne platform. You know, and the long shot I think is an example of, you know, that kind of model. Is that something that, you know, do you see that as the route to scale? Because I wonder if the ability to, you know, take off and land from a runway is going to mean that those vehicles are more expensive than you can really afford at scale.
Well, long shot, just so I explain what long shot is. Long shot is a very small, relative small, unmanned vehicle that carries 2 AIM-120s, okay? And the AIM-120s are a big fraction of their, you know, gross takeoff weight. Now, long shot can be air launched, it could be ground launched, it could be helicopter launched. And so ground launch, helicopter launch, that would be, you know, forward. If it were launched off of a fighter jet or off of a HAVA, then, you know, then what you're doing is extending the range of an air-to-air missile. So that's another way to go at scale. When you light that thing off, it's not coming back.
Right.
Yeah, so every day, and those missiles are expensive. The missiles are more important than what's carrying them, let's just say that. Yeah, so yeah, I think there's a place for both. Right now, you know, the big focus is CCA, and prior to that with AR4L, it was the off-board sensing station that we just flew, which I would say is a predecessor to that platform. All the same common genus, you know, parts, so we have the commonality. But I think there's hope for both of them. I don't think it's just one or the other, to be honest. Yeah.
So, you know, I'm really curious as you look to off-board sensing, CCA, other small aircraft. You know, what that changes about how you think about building an aircraft. I mean, GA, of course, is famously vertically integrated, and you know, strong emphasis on, for example, you know, carbon composite construction. A lot of that, you know, in-house internal capability. As you know, I go to an aircraft that has vastly smaller wingspan, operating at different wing loading, right? Do I need to use the same construction techniques? What does that mean for how we think about manufacturing? To what extent does this shift to smalls make you think about your supply chain, your vertical integration differently? To what extent do you have to adapt not just the design, but how you build these aircraft?
Yeah, no, that's a good point. I think, yes, we have been famously vertically integrated. I think, you know, the way it happened with MQ-1 and MQ-9, it was like, well, let's go try this, and then it was successful. Well, let's multiply it and keep multiplying it, and then here we are today. What's different on CCA and some other programs we could talk about is we're going into it with the thought of build a lot of these. It changes how you do it. It changes how you design it. So from the get-go, we're thinking about, you know, producing at scale. Not just getting the first one out with hot glue and, you know, sticks holding things together. You know, we're actually going into full rate production, bringing in companies that are used to building high quantities, team with us. So some of that vertical integration is, going away. And so that we can get a production line that meets their needs, and their needs are quite high. So our company has no problem doing it. We've built close to 9 aircraft a month before, and we can get to those rates again. But we're doing it different. I think that's the main thing. We are starting out knowing that we have to build a lot. It changes how you design. It changes how you look at things. And it isn't all composite now. You know what I'm saying? It is a combination of metals and yeah.
So you're moving some of that design for manufacturer consideration way up in the design cycle from where we typically do that.
Yeah, well, in the past, we didn't really have that, and then it kind of snuck up on us, and then it was like, well, don't change anything because it's working, Right. So yeah, I think every evolution that's gotten a little, MQ1, I could write a book on. MQ9 was, kind of wild too. That started off as a telecom airplane. General Jumper said, no, I want that, and I got a phone call, and it's like, we're in business on that one. MQ9 Bravo, that was really digital engineering and going into production for the certification piece. So, and this next phase is now let's do that digital engineering, share it with other companies that know how to build at scale.
Maybe I'll just, you're an engineer by trade, and you've been at Uncrewed Systems for a long time. Maybe I'll ask you, how long ago it was you worked in your first Uncrewed system. But
1980.
1980. There we go. Right. You've been in this business for a while. Where do you see the value of these digital engineering tools, right? Because, you look back at what you did on MQ1, MQ9, these are remarkable time cycles about how quickly you're able to turn around. And a lot of that feels like it is, small empowered teams, high quality people, this test, build, analyze, fix cycle. So if I already had the speed, why do I need to add the digital engineering? What is it that you're now getting out of this? Why are you choosing to apply these tools, considering that you already had speed?
It does two things. It gives us, from soup to nuts, the ability to, at any point, take a design and move it somewhere else. We've never had that ability. To pull it out of General Atomics in the early days would have meant nobody had known how to build it, because it wasn't that well documented. But to have it more documented, it doesn't come for free. Yeah. And you need to get the economy of scale out of it. So if you're not going to build a lot of them, I wouldn't recommend getting, too wrapped up. Just give you an example. In the early days, when we'd worry about flutter on MQ1, we'd put the payload on the wing and then get a Makita drill out at the end with a counterweight on it and move the drill, okay? That was our flutter test, Now we have full physics-based models and verify all the modes and, get flutter margins and everything else. But, so yeah, it works. Yeah, you can get there.
So it's important for scale, because you got to then be able, you can work with your suppliers and be able to bring in a broader array of suppliers, I assume, to get to the scale you need in terms of the construction of the actual vehicles. But then it also gives you this ability to be adaptable and change the design, evolve it going forward, right? Because Gambit, the Gambit series and what you're doing with OBSS is all about creating a modular design from which we can build a variety of different vehicles and that allow them to be adapted, not just in construction, but also in the field, I assume.
Oh yeah, so the modularity is not new for us. If you look at the systems inside of an MQ9 versus a Gray Eagle versus an MQ9B, they're very similar. So we reuse the same architecture, the distributed systems with the triple redundant avionics. All that is very, very common. The Gambit series is taking one step more. It's taking primary structure. Let's leave the same. The undercarriage, let's leave the braking, the fuel system, the propulsion. Let's leave all that the same as well. Now you get a really big leverage on being able to just reskin something and, and move on. The other, just of late, the thing we're doing is for some of the advanced air-launched effects, is actually building the airframe out of metal. This is sacrilege for General Atomics Aeronautical, but out of metal but printed, so additive manufacturing. And I think that's going to be huge.
So let's talk a little bit about that. Yeah, so the A2LE vehicle, for the Launched Effects Program of the Army, you working with Divergent to build those frames, to a digital design, in their facility. Does that give you the ability to, adapt that design and have a bunch of different variants that you can employ for, a lot of different purposes without really getting the normal cost you get or the normal penalty for going to that kind of diversity?
I mean, the amount of machining and redesign and fastening, you make 30 parts out of one part. You know what I mean? It's just excellent for the smaller platforms. And with the push of the button through, once you have your design, you can punch it over, and it makes you rethink about how you do things. There's no more tons of brackets everywhere and fasteners holding the brackets on and clamps and all this. It's all done, The outer case that holds the little turbojet engine on these things is built right into the vehicle. The fuel tank's built right in.
Yeah.
So imagine all that stuff goes. That's the beauty of additive manufacturing. You can take 50 parts and do it all in one part,
right?
And
then you focus the modularity on the payloads, the mission systems that go
and
inside.
if they need a new payload on the front end, it's redesign it, print it again, and off you go.
Yeah, so and that's something I think is important to bring out, is that you could have multiple providers for the same payloads, even if they're slightly different in terms of the form factor, because you can just build a bunch of different frames to accommodate those different internals.
Yeah, but let me, so what we've been focusing on, and what we're just talking about now is something I would call a large, small, okay? It's a 200-pound class air-launched effects, if you will. And the reason why 200 pounds is important, because to really do something meaningful at any kind of range, you need about 40 pounds of payload and about 1 kilowatt of power. And so that's kind of our sweet spot, and we can wrap different things around it. So we really believe something like that could be huge, like in Ukraine. Mm-hmm. How do I say this? You're penetrating their IADs without escalation, because you're taking this little thing in there that can penetrate. So penetrate IADs without escalation. Yeah, we could penetrate IADs with a F-35, right? But now we got World War III. Now they're in there with a bunch of smalls, and they're gonna shoot some down. But if you launch enough of them, and they got exquisite decoy electronic warfare in them, combined with warheads, and you don't know which one's which. If you had that at scale, I think it'd be a big deal right now.
So how
200 miles, that's all you need to go.
How do you think about the trade on system recoverability? I mean, you already hinted at this too. Eventually this gets into how you think about operational concepts.
Yeah.
Like at some small size, I don't care. At some size, I start to care, and even if it's only during a flight test cycle, how do you think about that trade, about the cost one should pay for the ability to recover, whether in a test environment or operational environment?
Yeah, it depends on the mission that you're doing. Like I say, it goes back to what we call attrition tolerant. But you can't go broke by launching mass amounts of these without getting some of them back. So CCA has to have a cost point, which I can't talk about, but it's a factor below what you mentioned before, right? It can't be that number, because you're close to a fighter jet.
Right.
Yeah. So it can't be that number. Cannot be that number, and we all agree. But on the flip side, if you're only going a couple hundred miles and you got exquisite sensors in there, maybe 300 grand per vehicle is something you can handle. Yeah. In a test phase, if we want to get a platform back, we typically have a flight termination system with a parachute, excuse me, and blow a cover. You know what I mean? That's a lot of fun. So yeah.
Going back, if you don't mind, on another engineering trade. I mean, you mentioned Gambit, and you mentioned the sort of common core. But look, there's a price to pay for that too. I mean, if you have to design your landing gear to meet all configurations, all wings, that means your landing gear's over-designed for at least some of them. How do you think about that trade? Why does it make sense to do that on Gambit as opposed to, 5 individual point-designed vehicles? Why is that the right trade in that size class?
Well, when we were able to design and build our own landing gear in-house was the happiest day of my life, okay? Because there was a point when Avenger, we were buying landing gear, and that was painful. Because if you're not, there's landing gear houses out there, but if you're not building a lot of something, they don't even want to talk to you, okay? So out of necessity, like many other things we do, we're a very capable undercarriage landing gear house. And it's tricky work. It's probably some of the toughest part of your structural design is actually your landing gear. Yeah. You think of all it has to do, depending on what it's doing, and land at 10 feet per second, and limit the G's, and we do our own anti-lock brake systems. And, have to align that with an all-electric airplane. Yeah. That stuff's not out there. So it's a lot of development that you can forego. Just like a fuel system. Fuel systems are, sometimes 8 tanks buried in weird places in the airplane, and it all have to be valved together. And if you can not have to redesign that every time you turn around, it's a big, big savings. Fuel systems, undercarriage, and then propulsion integration and pressure recovery and making sure that you're not losing thrust on your engine. If you can save all that, it's huge, huge.
So let's see if this is a fair summary. So you know that your customers, you know that there's demand here, there's a lot of need here, but at the same time, your customers are still maturing and knowing exactly what they want. And you see the volume that's going to be spread across multiple use cases. And you're accepting a little bit of performance penalty from if you knew a point requirement exactly to get this modularity where you can get this big scale leverage on your design and all the investment it takes to make that work. There's some performance penalty to accommodate future options. You keep your future option space open. Right. Is that a fair summary?
Yeah. I would say you build some margin in, so if the next version of the aircraft, you're okay flying slower and had a longer takeoff roll, then maybe you're all right with the gross weight going up 30%. And you're okay with the gross weight going, say, below 30%. That landing gear needs to cover
all of that?
Yeah. That range. Huge savings, in design and the design cycle.
So one of the reasons we were sort of touching on the idea of scale and adaptability before is related one to the report, talking about the Hedge force be specifically proposed for the defense of Taiwan, would rely on unmanned systems to be able to disrupt and slow a Chinese invasion across the Taiwan Strait. It would need to do it without a lot of warning, and so in some cases you'd have to deploy in advance, within 24 hours or so, or in some cases it would have to fly there from adjacent islands like in Japan or in the Philippines. So that range of 200 miles is really relevant. The cost point that you're talking about is really relevant because you can get the scale to be able to do something useful against an invasion fleet. And then adaptability is really important because once you field this thing the first time, your adversary is going to build countermeasures, and now you're off to the races in a counter-move competition. Are you thinking of that in terms of like the drivers behind the need for adaptability and scale? Are you guys looking at trying to satisfy those use cases, like that? Like what you see in Ukraine when they're using these systems against the Black Sea Fleet, or what we might see in the Taiwan Strait?
Yeah, let me ask so way back in the beginning, we were like wild cowboys, right? And then it was decided, you guys need to normalize, right? So then we normalized. And now I think, with your Hedge idea, we need to unnormalize a bit. Yeah. Okay, and take some of these, there's a ton of assets out there. Take some of them, go put new sensors on them. Mm-hmm. It is low-hanging fruit that you can do today. What are those sensors? Strategic SIGINT pods that, you know, if you're a boat that can carry a SAM on open water, you can't hide, okay? And if you chirp, and these SIGINTs, they grab you, we've got you. Hold custody. So comment, auto ELINT at range. You're not in their threat dome. You're standing off. And oh, by the way, you can target them through standoff. You can do that with MQ-9As today. All you need to do is pull a fuse set out and do a QRC or a hedge, put these new sensors in there, get a different satellite system, and get, some of these are older airplanes, get resilient nav and comms in them with different satellites we won't talk about, but those are easy to go do. And the Air Force is actually moving out on quite a few of these. You hook that up with Link 16, real time, into the fleet. That's a huge ad right now for Taiwan. And that, we just got under contract with Taiwan, so people are thinking about it. So, during
your smalls.
Yeah, but during phase 0, when, nobody's going to shoot you down. And that's like a bad day, right? But you've got the whole battle awareness. You know where ships are that can shoot, shoot you down. You can just keep everything and keep in custody. When it gets into a real conflict, I think air superiority has really got to come in, and I think that's where Secretary, Kendall's got the right idea that you just mow in with these CCAs and push everything back.
You bring up an interesting point, though, is that, talking about this idea that we were trying to mainstream unmanned systems. You're trying to bring them into the force and have everything be manned and unmanned teams and loyal wingmen. And, we're finding there's challenges with that, right? Because if you're going to have the manned stuff, work with the unmanned stuff, all the problems you mentioned in terms of, working through the just coordination and deconfliction. But also, what are the operational concepts? I mean, are you going to constrain the manned platform to the unmanned system's utility, or are you going to do vice versa? Whereas, the Hedge idea is, maybe we take these unmanned systems and they're kind of in their own force and they're operating mostly with each other to free us up from some of those constraints that come from trying to, make everything a manned-unmanned team. Is that something, do you see that as like the future in a lot of ways? You see that with Ukraine. Their Ukrainian Navy is pretty much an unmanned Navy at this point. You see with what's happening, on the ground is a lot of unmanned systems being employed as the primary mode of attack.
Well, so the Air Force has a modernization program for MQ-9A, and they're building a lot of these kits that we're talking about with, resilient comms and GPS, and they haven't really embraced the strategic SIGINT yet, but the Marine Corps has, and the Marine Corps is flying MQ-9. Just to be a little critical, I think what's happening is it's going too slow. And the ways I'm going too slow, it's like, well, let's build up the kits and make heel toe, and it's got to get in the whole fleet, and I'm, how about an idea where you pull, 24 aircraft aside, they won't miss them, just pull them aside and make a Tiger team, that gets over there and does some special stuff and bring in these sensors. You can, with 14-inch lugs, you can click on a sword pod that has all the strategic SIGINT at a, the drop of a.
Yeah. So I want to dig into this a little bit. You're painting this idea of this really dynamic integration model where I'm evolving my tactics, my operational concepts, bringing on new payloads, new software loads. It's quite dynamic. I'm pushing that integration as far forward as I can, right? So this is really far away from like the requirements process early on before a program starts, and this is really quite forward. I'm coupling really my operations together with my development. I think that's really compelling. Bryan and I spent a lot of time talking about how much potential here. One technical challenge associated with this is how we think about software. Most classically for aircraft, right, we lock an operational flight program, OFP, the software of an aircraft down early, and I only ever update that after a really extensive testing process, right? Which means I have several years between software updates. As I think about this kind of snapping new payloads on, but maybe snapping on also new autonomy behaviors and new collaborations, like there's a lot of changes to software. Everything from the CG of my aircraft is changing to I have to pass a new message to my mission systems from my SATCOM link to other autonomy behaviors. Can you tell me how you think we can safely manage that, and like where GA has had to invest in new processes, new technology to be able to accommodate more dynamism around the software?
Well, we pushed for years for that open mission systems. It does what it does, puts a firewall between the flight critical and the mission system, such that as long as you're not talking autonomy of flying the aircraft, you're just talking about missions, equipment, then we can load it in without, in my opinion, without going through an airworthiness cert, because you've got that firewall. Those kits are being developed as we speak today, and they include Link 16. So the Air Force is, the normalized program is moving forward with these changes. All I'm saying is, let's take that and not wait to have it across the whole fleet.
Yeah.
Let's pull some aircraft aside and go focus.
Yeah,
with those kits.
Yeah.
Yeah, and learn.
That makes a lot of sense. What about in terms of actually core flight control and core automated flight control and flight control laws? To what extent, have you invested in, you hinted at this earlier, like digital test beds, et cetera, where you can automate a lot of the testing of a package that would let you know that it's a, hardware in the loop test beds, et cetera. How much automation can I add into my testing process to know that these software updates are safe to push?
Yeah. No, you're identical. So the difference here is, and like I was mentioning with our Skyborg program with MQ-20, is once you bring autonomy in, and autonomy is going to fly the aircraft, okay, then we have developed through our Skyborg program a thing called a validator. And the validator is part of the airworthiness side of flight controls. And it talks to or receives commands from the autonomy. So if the autonomy says, fly over Washington, D.C., we say no. Okay, there's fences, geo-fences built in there. If the autonomy says, fly upside down and go, Mach 0.4 straight at a mountain, no. So there's limitations for bad things, bad commands. And what that does is now it's safe, right? You can't tell me to do something stupid. That's probably not the best word. But by mistake, right? And you can iterate your autonomy, which if you can't iterate your autonomy, you'll never get there. You have to iterate, fly, fix, fly, fix, fly. We make fixes on the fly into the autonomy software. And that's where you need to get to. But you got to be able to do that without going through an airworthiness board every time you're done. It'll just take forever. So that validator is, early on, we're like, how do we do this and meet the need of lots of data to the autonomy engineers so they can fly, iterate to get better. Because they need data to do their job.
That's right.
Yeah.
Yeah, and this is one of the things I find exciting. I think it's probably not obvious to a lot of the public who looks at drones that like this is one of the core problems that you would have to solve. It's like I really have to invest in the ability to automate a lot of this test in order to. I still have to know it's safe, and yet I have to accommodate this really rapid rate of change that I didn't used to. But this is implied by autonomy. Yeah.
Yeah, and what's important is when we do a factory tour and people come in and they hear the word drone. They walk into our factory and they can't believe the size of these things. Yeah. These are big, big airplanes. And, they can be dangerous. So you got to be careful with them.
So to what degree, you talked about, separating the mission systems from the autonomy and the flight control, which would be kind of a standard way of managing this challenge. But you lose something in terms of not being able to leverage the mission system as an input to the flight control. Are you still able to take advantage of that integration?
Oh yeah, but it's done on the other side.
Right.
It's done on the other side, yeah.
So that's happening
in the autonomy engine.
Okay, so that goes into the autonomy engine as opposed to going into the flight control.
So I'm talking about the commands that actually go, okay, go do this.
Right.
Fly there, go this speed, turn, climb, descend.
Yep.
Those are the commands that you don't want to, crash an airplane with. Yeah.
But this is a common challenge, amongst all the kind of unmanned system manufacturers that we talk to, is how to balance the integration of the onboard mission systems with the autonomy and the flight control, the operational control of the system, because you're unlike a manned system where a human is doing all that integration. Now you've got to you have to be deliberate about how you do it.
Oh yeah, and then, if you had somebody sitting in the unmanned aircraft, he'd know, I'm not doing that.
Right.
I'm going to turn that off. And that's basically what the validator's doing. Right. Saying, no thanks. Yeah.
So I wanted to alert the audience. So we are going to take some questions for the audience. So if you have questions, raise your hand. And I think Morgan has a microphone that she can bring around to you. There she is. So, we have a question right here. We'll wait till Morgan comes around, and then let us know your name and affiliation. She's coming. She's right there. Thank you.
Chip Walter, Mullen Spike Partners. Got a question for you. First, this is great, fantastic. Really appreciate the insight in terms of going to autonomy. It's really, I won't ask a lot of questions, but I have some. So, how much do you save getting a person out of the cockpit on the cost of the aircraft, the weight, all that stuff? It's a leading question. Don't bother answering it. The point I'm getting at is, why are we even doing this? Why do we have why is FCA, NGA, why do they have people in the cockpit? Because how many of these CCAs, loyal wingmen, can one F-35 actually manage?
Well, okay, so you don't have the microphone. I guess you're done. She took it away from you. Yeah. Yeah, no, okay. I would say the F-35 or whoever's got a tablet on his knee because he's trying to stay out of the OFP of that, is not flying those airplanes, okay? He's giving high-level commands, okay? The autonomy is flying the mission. And until you get to that point, that F-15 pilot or whatever, he's going to be saturated, I think, a little bit here. To me, maybe the loyal wingman thing is a good start, but where it needs to go is fully autonomous. Send out 40. He's F-15 guys back here waiting to see how it went. Okay, then maybe 2 come in with him or something to pick up stragglers. That kind of thing. We have sat with F-15 pilots that are in the training school just to sit down with them and go, what are you going to do with this tablet? How's this going to work? Because, they have a very, very integrated weapon system across multiple. It's pretty awesome, what they have for the pilot. And then he got this thing, on his knee. So, and to break into his whole stores management weapon system would take years, and we don't have time for that. So there's a mix here. I think the tablet first, and then next is just get them all up there, let them go. So,
Dan?
Yeah, on a total change of pace.
Yeah.
Another great, one of the really unique things about GA is, of course, it's privately held. Can you tell us a little bit about how that difference, or maybe GA's culture or your view, changes how you think about investing in the future? How do you think about your IRAD? And how do you balance some of these future things we're talking about, like smaller aircraft and leaning forward with that?
Yeah, so I don't know if everybody knows, but General Atomics Aeronautical Systems is privately held by basically one chairman. And he's a patriot, and he loves his country, and he invests everything right back into the company. So the IRAD budget that we enjoy every year is quite large. Several times what normal industry would be. Now that I'm president, I have to balance all that and hit things at the end of the year. It's got its own difficulties, but the beauty of it is, we're able to go build things and show people how they work, and and bring new aircraft that aren't a me too. They're something different. One of our airplanes right now is a flying wing hybrid propulsion. And the amount of hours you're going to get out of that without refueling is eye-watering, eye-watering. 3 times the TSFC of a normal buried turbofan engine. Cold air in, it's a vacuum cleaner flying in the sky. Cold air in and cold air out the other side. So it's those kind of things, of ideas that the owner is embracing, you know, that make a big difference. The other big difference is leaning forward on a production line. Production lines are kind of like a catch-22, where, you know, it's like you can't do the production until you have the customers, you can't get the customers until you tell them what the price is. And so we run our production lines like a commercial company, where we lay it all out at risk to get the learning curves down, and then we offer that learning curve to every customer. There is no cold start at our company. All customers get the same good deal of economy of scale, and that's really unusual, because the amount of money it takes to lay out 100 airplanes at risk, if you do the math on that, and money's not so cheap these days. I mean, it's not 1.5% anymore, yeah. But anyway, those are kind of the 2 big differences, I would say, and it's just the culture there is, you know, you decide to go do something, we go do it, yeah.
Other questions? Yes, ma'am, in the back.
Thank you. I'm Catherine Katz from Fresh Fields Broadcast Derringer. So thinking about the future as these become cheaper to make, easier to operate, lighter, kind of just, you know, mass production becomes much more feasible. And maybe this is a bit more of an existential question, but to what extent do you foresee that change in operability and availability fundamentally changing decisions on whether to end or prolong states of armed conflict?
Oh, well, I'll try. If I don't answer your question, ask it again, but I think I got it. Well, I think you deter by, you know, by persistence. So in a phase 0 part of the war, if you got a long endurance platform that has all these sensors on it that we're talking about, and people know you're watching, they act different, okay? So I think that part of deterrence is hard to measure, but I think it's huge. So a country that's doing this phase 0 along a border, knowing that we're picking up everything they're doing across the border, you know, they're not going to project. They're going to stay back. They're going to act different. So I think that part of it slows things down. I think if once we could get into you know, this whole maritime environment, it's somewhat the same, but now you can actually hold dangerous surface action groups that are out there you know, you can hold them custody with persistence that you couldn't do before. So I think that's a big game changer for flying in big blue water. And then so, you know, you've got over land persistence, now you got over water persistence, with custody of you know, very dangerous ships that are floating out there. And then lastly, I think if we can bring in mass quantities with air-to-air combat, I think we've come full circle with unmanned solutions. The last one being the most important for air superiority, which we are not going to get without mass quantities. So I think the CCA program, I know there's a new administration coming up, but I think it's really important for the country to embrace that concept, because I don't see any other way to keep air superiority going forward without mass quantities. And once you have air superiority and all those other things I just talked about, I think nobody's going to mess with you. So did that answer your question?
To build on it a little bit, David. Yeah. So you know, you talked about deterrence and the likelihood of protracted conflict, you know, driving us to, you need mass to be able to compete over that kind of time scale. And we're seeing in Ukraine, you know, how they run out of weapons, they're having to turn to other systems like unmanned systems as an alternative. So the smalls, and you talk about, you know, getting to scale at things like with things like CCA, with things like Gambit. You know, it seems like that's an element of deterrence, is having that ability to mobilize and get to scale with adaptable systems, can present your potential adversary with the threat of staying power, and then something that could evolve over time, and get into a counter-move competition. It seems like that's an element of deterrence as well.
Oh yeah, no, I agree. And I think if Ukraine had hundreds, and I mean hundreds of the large small UAS, with that 40-pound payload I was talking about, where you can penetrate IADs without escalation, I think it'd make a big difference for them. It's almost like the CCA in a different way.
Yeah, right.
I mean, it's a 200-mile CCA.
Right.
You know what I mean?
Right. Well, that's what in the Hedge
Instead of a
report. So
1,000-mile one. Yeah.
We talk about this idea of you can use that for essentially domain denial, over a short distance, which might be enough. If you're just trying to stop somebody from doing something.
Yeah. Right now they just got an IAD stalemate going on right now. Right. So they just lob things back and forth. So I really think that'd make a difference.
We have time for one more question, sir.
Skip Barney with AVEX Aerospace, and my question, you bring up the CCAs, and that's a great concept for the United States, but when you're talking about the spaces we're dealing with, particularly in the Indo-Pacific, with our allies and partners, what are your thoughts on the fact that the technologies that make these systems work are so tightly controlled under ITAR and export policy? And so I think it limits us when we've got allies that could be surrounded by a very sophisticated threat, but to get the U.S. Air Force there to operate CCAs is behind timeline or maybe not the scale that we need.
Yeah, no, that's a good point. I really think, well, the special sensing that's inside CCA, I mean, you brought this up, so you obviously know, probably not easily shared internationally, right? But if you really want to bring something to scale, I think our allies and us need to come together and pool funds and pool production. And maybe, 3 countries are building the same thing, and some of that sensing equipment, if we want to hold it dear, because it's critical program information, but still you got to be able to share it with these countries, that get in there and help build the platforms to go with it. I think you've got to pull everybody together. Imagine that, if 5 countries were making the same thing. Imagine that. It'd just be voluminous, game over, right? But instead, it's like everybody's in their stovepipe. Yeah. Well, anyway, it's easy for an engineer to say for everybody to get together and
That's right.
share their wares, yeah.
But that's where modularity can come in too. I mean, where you're going with CCA and modularity, could enable you to swap out those mission systems for ones that are exportable, and maybe that makes it an easier lift to be able to have the underlying carriage is shared, but maybe the mission systems are.
There's ways to share, but not expose the CPI.
Right.
Is all I'm saying, and even that is so hard to do, because you can protect things, but still, we're all doing the same mission.
Right.
That'd be huge.
Yeah.
That'd be huge. And with this zero-sum budget, that's out there all the time, and start, stop, and
Well, we can end on an optimistic note.
Oh, sorry,
I
was like bumming everybody out.
International cooperation and the
On that
opportunities
note,
for
yeah.
that. That's right.
Yeah. Sorry.
And we've got an appropriation, so everything's good.
Yeah, no, it's all good.
Well, but I want to thank you very much, Dave, for being here with us today and for giving us your time. And
Yeah, thanks for the great questions. Yeah.
Thank you very much.
Thank you.
And thank you all for being here. We appreciate the time you took today and your questions. And for Dave Alexander, for Dan Patt, I'm Bryan Clark, and thank you for being with us here at the Hudson Institute today.